So there's this yo-yo spinning, and it's going at 4,400 revolutions per minute, which means times around. And I want to know how fast is the edge of the yo-yo going in miles per hour. So here's the situation. You got your little yo-yo right here, and it's spinning around really fast. And I want to know this dot on the outside, how fast is that going? So what we're going to do is set this up like a unit analysis problem. I tend to not do formulas if I can avoid them. I like to reason our way through this. So let's take the speed that we want, which is question mark miles per 1 hour. Okay, that's what I want the units of the answer to look like, miles per hour. And what I'm given is a very different speed. This is 4,400 revolutions, which I'm just going to call rev, divided by 1 minute. So you can see the units don't match on either side of this thing. I've got speed on both sides, but on one side it's linear miles per hour, on the other side it's angular revolutions per minute. So what I'm going to do is multiply this by fractions to get myself to the desired units. So the first thing I notice is I've got minutes on the right. I don't want minutes, I want hours. So what I'm going to do is multiply by a number of minutes over the hour. Now, what that's going to do, first of all, the minutes are going to cross out, right? And I'll have revolutions per hour. That's great. How many minutes are there per hour? Well, there's 60 minutes in 1 hour. Okay, so that's my first calculation. Then I need to do another multiplication, and I need to address this problem over here. I want this revolutions to turn into miles. Okay, I don't want revolutions per hour. I want miles per hour. So let's see how we can do that. What I need to do first is put revolutions on the bottom of a fraction, okay, to cancel it out. So 1 revolution. Well, how far around is 1 revolution? I don't know how far in miles, but I do know that this thing is 1.26 inches in radius. So I can say that's 2 pi times radius. Okay, so or 2 pi times 1.26 inches. Now, if you're wondering where that came from, that is the formula for circumference. Okay, that's the circumference of the circle. Great. Only problem is now it's in inches, and I want this thing to be in miles. So a couple more steps are needed here. It's going to be times something with inches on the bottom. Okay, I'm going to say 12 inches and 1 foot on the top. All right, so that turns this thing into, if we're going to follow along here, see that's going to cancel out my revolutions. Whoa, that's really big. Let's not do that. It's going to cancel out my revolutions right here. Okay, revolutions are gone. And then the next step was I cancel out my inches. Okay, that's right here. And I need one more step. This thing's going to cancel out feet and turn it into miles. So the question is, how many feet are there in 1 mile? It's 5,280 feet. You can complain to whoever set up that system, but not really important now. All I want to do is cancel out the feet. So if you look at what's left in this big old mess here, I've got hours on bottom and miles on top. In other words, this is going to be a miles an hour problem once I finish calculating all the numbers. So let's collect all the numbers. This is going to be 4,400 times 60 times 2 pi times 1.26, and that's it for the top. And then on the bottom, I have a whole bunch of ones. Okay, we got 12 times 5,280. All right, so you just have to calculate what that fraction is equal to. Now, if it were me, I would calculate these on the bottom first, calculate these on the top next, and then just make a single fraction before I got my answer, because if you mess up on the parentheses, your whole problem is going to be wrong. So you want to be a little careful when you actually do that calculation. But you should get 32.99 in this case, and it's going to be 32.99 miles per hour, matching the units that were not canceled.